All right, so today I'm going to do a randomly generated maze. I'll hit my play button and you're going to see it form. And I put some wait statements in so you can actually see it work. Right, so here it is. In a few seconds, it's going to start carving out a maze. Any second now. There you go. All right, and it's just going to go through there and it's going to get every single tile, make sure there's a pathway to each tile. So while that's doing that, let's go to this Wikipedia page right here. I'll put this link in the description. Maze generation algorithm. I am using randomized depth first search. It's also called the recursive backtracker. And I'm going to do the iterative implementation right here. So you could read a little bit about that if you want. I'll do a little bit of explaining, but I'm not going to go too deep into theory because I want to just actually make it work, right? These are Roblox people. They want things to work. There we go. And that's our finished maze. I think that's pretty cool. I can change the height of the walls, the thickness of the walls, the thickness of the pathway, all that stuff. So let's go ahead and get a fresh world and get started with that. All right, so here's my fresh world. I'm going to get rid of the spawn location because that's where my maze is going to start. Boom. There we go. Workspace, hit the plus sign, add a script. Let's call the script maze gen. All right, we're not going to add anything else in the world, so we can go ahead and close these windows. All right, and even the output window, we'll open it up when we need it. We'll make this a little bigger so you can see it. There we go. Let's do some variables. All right, so we'll do a variable for the maze. And that's going to be just an empty table. And it's going to have rows and columns in it, right? What else do we do? We're going to get a path width. That's our walkway width. It's also going to be the tile. We're going to do 4 tiles that are squares. So each one of those will be a path width in length and width. All right, and then we'll do a wall height. We want to be able to change that, so we'll do a variable for it. We'll do a wall height POS for position, and that's going to be the wall height. Oops, what I got to do? Wall height divided by 2. Right, because we've got to put this by code. We're going to put it in the world by code. So everything's going to have a variable. Then we'll do a wall thickness. We want to be able to change that. I'll make it 2. I think it was 4 for the demo. And then I'll do a wall length. That's going to be the path width, which is the square, the tile, plus 2 times wall thickness. 2 times wall thickness. Because we want a little bit of bleed over in the corners because we don't want to have gaps. Right? And then we'll not bleed over, but bleed through, right? We want the walls to meet. All right, we'll do a wall offset. What is that? Well, if we get the path width divided by 2 and the wall thickness divided by 2, we're going to put the wall right where the tile is, what the wall belongs to, and we need to move it over half of the tile and then another half of the width itself so that it sits right beside the tile, right where we want it. All right, let's do a floor height. That's going to be pretty trivial. We'll just make that 1. Floor height POS for the position of where we're going to put the part for the floor. There we go, divided by 2. We'll do a floor tile distance. All right, so that is the distance from the center point of each tile. We need some sort of multiplier for this because we're going to add it with loops. So we're going to do the path width plus 1 wall thickness, right? Because we're going to have the walls in between those tiles. All right, now let's go ahead and make a stack, right? So a stack is a data structure. We're just going to make a table. We're just going to use it as a stack. In a stack, what you put on the stack last is the first thing you pull off, right? Like, so if you have a stack of dishes, the last dish you put on the stack, if you need a dish, you pull that one off, right? So that makes sense. That's pretty cool. And you'll see how that's used. But let's insert our first value into the stack, right? And that's going to be where we start. So these are curly brackets. These are curly brackets too, right? Curly brackets. Z-val equals 0. So Z is going to be rows, X is going to be columns. So we'll start with the 0, 0 position in the maze. All right, what else do we need? We need rows and columns. So columns We'll just make this like 5. We won't make it, I think it was 12 and 12 in the demo. And then do rows something different. That way, if you get your rows and columns, if you get something mixed up in your code, you can change those and you'll see an error quicker and you can fix it. All right. We also need a random number generator. So I'm going to say random new. There we go. All right. So those are our variables that we're going to need. Let's go to make our first function, local function, create part. All right. Part's going to have an X, a Y, and a Z for the sizes, a PX, a PY, and a PZ for the positions. We'll say part equals instance new part. We'll go ahead and put that in the workspace. That's the parent. We'll anchor the part because it's no fun if walls fall down in a maze. And then we'll set the size, vector 3. It always gives me that vector 2. There we go. And that's going to be X, Y, and Z. Part position, vector 3. Ah, nice. New, PX, PY, and PZ. Oh, and the default parts are going to have that Lego surface. So let's go ahead and do a top surface, enum, surface type, smooth, just so we don't have that Lego look on the top. We'll return the part. Sweet. All right, so now we got to go ahead and make a floor. So let's do a local function, create floor. Cool. All right, so floor, what we're going to do is we're going to do 2 for loops. So we'll say for z equals 0, we're going to start with 0, not 1. And then we're going to go rows minus 1 in steps of 1, do. So I'm going rows minus 1 because we're starting at 0. If we have 5 rows, it'll be 0, 1, 2, 3, 4, right? So that's why we do the minus 1. All right, and then we need to initialize our maze. So we have our maze for the row, right? There you go. That's how you do a 2-dimensional array in Lua. And then we'll do a z equals 0, calls minus 1, steps of 1, do. Cool. All right, let's get a position for our part. We got to get a floor tile here. All right, so we'll do position X. We have our X, which is our column. It's going to increase every loop iteration. We're going to multiply it by the floor tile distance. And that's going to make a nice little, it's going to spread them out based on X, right? And then we'll do 1 for the rows, right? And that's a Z. Floor tile distance, nice. Let's make our part. We have our create part. We're going to put in our sizes. That's path width, floor height, path width, because it's a square. Then we're going to do our position X. We're going to do floor height position, right? There it is, floor height position, and then position Z. Nice. All right, and then we're going to get our maze. We have a 0, we're going to have a Z column, curly bracket, and we are going to make a field in our table called tile, and it's going to be equal to the part. All right, let's give it a shot. Let's go ahead and make a call to create floor and see what we have. It's looking good. I'm not even going to check. I'm just going to hit plus. If we get errors, here, let's take a look at our output window. Then we'll know we made a mistake. Ah, look at that. No errors. We got a nice little grid there. Let's go ahead and put some walls in there. All right, so we have our create floor right here. Let's get rid of this so we have more room. Let's make a create, local function, create walls. Sweet. I spelled function wrong. There we go. There we go. All right, it's going to be very similar to this. Let's go ahead and copy this. Copying and pasting is dangerous, but at least you don't have to watch me like kind of type things out all the time. I'm going to get rid of that maze initialization. That would be bad because that would get rid of all of our tiles. We would just be like wiping out our old table. This is looking good. Let me put a note here. I'm going to say, which walls should we make first? Let's do, say, east walls. East walls. All right, so east walls. This is right in the center of our tile. So what do we need is a wall offset, right? Wall offset. Nice. And then this is okay. We can use that. This has to change. Let's go ahead and say wall thickness for this one. And that took playing around with, right? I didn't figure that out right away. I was getting funny looking shapes there. Wall height. And then this is going to be wall length, right? So that's the size of our part. And then the position X, well, we modified that. Ooh, we don't want floor height. We want wall height position. And then position Z. This is no good. Let's get rid of that because we already initialized our table. We're just going to add a field. And in Roblox, you can with Lua, you can just add stuff on the fly. So this is going to be called the east wall. And it's going to be equal to that part. All right. Now we have east walls and we have west walls. What are we going to do? We don't want to make two sets of walls. So what I'm going to do is I'm going to go maze Z, and then I'm going to take a peek over here to the right, that next tile, see if it exists. If it does exist, right? Let's go ahead and make a west wall. Is actually the same part, right? So the one to the right is west wall is going to be the same as our current east wall. Makes sense, right? Should we take a look? Let's take a look. Copy this. I'm going to paste that down here. Boom. I hope everything's right. There's a lot that can go wrong here, right? So there's going to be corrections. I'm not going to be able to get it all right the whole time. But that's looking pretty darn good. Let's go ahead and do south walls. So we'll start with this one, this one, this one, this one. We're going to have to add these edge walls last. All right, so let's go to make our south walls. That's right, south walls. I'm going to copy this. There's going to be a lot of overlap. Copy. Let's put a note. South walls. Boom. I should just change that. There we go. So south walls, we're going to change our position a little bit. We're not going to need an offset on the X. We're going to need an offset on the Z. Cool. We're going to create our parts. Let's go ahead and get rid of this wall thickness. This is going to be wall length, right? So we need the walls running in a different way. The height is good. And then this is what wall thickness. We just did thick, wall thick. All right, so the X, that's fine. We change that up here. Height, that's good, that's good. So right here, these are north-south walls, right? So I'm gonna make this a south wall. Oops, I got rid of my dot. The south wall. Now south is a Z thing, right? So we don't even wanna check the X. We wanna check to see if Z plus 1 exists. If we can go down, if we're all the way down on the bottom, the Z plus 1 row won't be there. So we got to check to make sure it's there, right? If it is there, then we know that that X will be there because it's a column. And this is no longer west. This will be north, right? So we got north and south walls except for on our edge conditions. Let's go ahead and take a look real quick. A lot can go wrong in this, so we're going to do a lot of checks. Boom. All right. Let's add our edge wall along the west and our edge wall along the north, but we're going to leave this one open. All right. So our edge wall along the west is going to look a lot like just these three lines because we're not actually going to store it in the maze because we're not going to knock any of those walls out. right? So we don't need that part. Let's go down here. We'll say west edge walls. All right, this is going to be the same, except let's do this. It's only going to happen when x equals 0, right? So it's only going to be on that edge condition. Let's put that if statement in there and go ahead and format that. All right, so if this is only going to be 0, this obviously is not going to be anything but 0. So we can get rid of that. And we don't want the wall shifted over to the left like it has been. We want it scooched over to the right. All right, this part actually looks good. That looks good. All of this looks good. All right, so do we feel lucky? Should we test it? No, let's not test it. Let's go ahead and just do the other one. Let's do it if. So z equals 0. This is the north wall, right? Z equals 0. Oh, and then we want a little opening on that first tile. So x not equal to 0, right? That'll work. Let's go ahead and put a note here too. Let's call this north edge walls. All right, it's going to look a lot like our south, but it's going to be north. Copy that. Paste that. Right? And this is always going to be 0. And we want to scoot that up, which is also a negative number. I think we're good. Oh, you know what else we can do? We can get rid of this because we're not storing this in the array. So we don't need a reference to the part. We don't need a reference to that part. I mean, you can do it. It's not going to hurt anything. And let's check it. Let's check to see what we got. There we go. That was our west walls that we added, the edge walls. This was the north edge walls. Cool beans. All right. Now we're ready. We're almost ready to start our implementation. Well, the implementation of our algorithm, I should say. We've already started the implementation, but that was just Roblox stuff we've been doing. Now, let's go ahead. Oh, you know what? We need another helper function. We need a function to remove walls. Remove wall. We'll pass the wall in. Oh my gosh. Do I have cap lock? There, I had cap lock on. There we go. And then what else do we need? We're going to do a function to redraw the maze. So we'll say redraw maze, right? So when we go to knock a wall out or something or color something, we're going to redraw it. What else are we going to do? The actual algorithm itself, we're going to have this function for get unvisited neighbors. So that's how the whole algorithm works. What we're going to do is we're going to take a tile and then we're going to look at all the neighbors that exist and haven't been visited, and then we're just going to pick one and go in that direction. When we run out of neighbors, we're going to back up until we find a tile with neighbors and then go the unexplored path. That's why it's called recursive backtracking. And let's see, we're going to do another one, another function. This is going to be search path. I guess it should be like traverse, but I might not spell that right. So I'll just do search path. Alrighty. Let's go ahead and complete this down here. We got our create walls. Let's initialize our 0, 0 element in the maze. Right, we got a tile in there, and then we're going to get this visited field to equals true, because that's where we're starting. So it has been visited, right, by us. It was the first thing we did. Let's wait like 6 seconds to get in the game so we can see it working. Production game, you might not want waiting, right? And then I'm going to do this loop. I'm going to say while search path do will redraw the maze. So search path is going to traverse the path looking for places that haven't been visited. It's going to return true until it's found every single tile in the grid, right? And then we'll redraw after every visit. I'm going to put this weight in here just so that we can see it happening. You might not want that in your production game. However, if you do tiles, if you do a grid of more than 40 by 40 or 30 by 30, somewhere around there, you're going to start exhausting your resources in Roblox. So you might need the weight anyway, right? But 10 by 10 and 12 by 12, you'll be fine. And then let's just go ahead and print out a finish so we know when it's done. Cool beans. All right, let's start working on this. All right, so search path. Here we go. Let's take a look at the stack, all right? So the stack, it should not be nil, but let's just check to see, make sure it's not nil. Or if the number of elements in the stack equals 0, if any of those things happen, we are finished. We're gonna say, oops, false, there we go. It's all going to be stack based. This is our exploration. Stack has all the tiles we were exploring, right? So we'll say local, let's get a stack cell, right? And we're going to get it from the stack, and we're going to use the number of elements in the stack, right? So in computer science, this would be called a peak, right? You look at the top element on the stack and you're getting a reference to it. If you remove it and get the reference, it's called a pop. So if you're taking a computer science class, that's some of the terminology they're going to use. We're just going to get an element to it, right? You'd be all right not knowing what that means. All right, so stack cell. Remember, we put an X value and a Y value. So let's, or X value and a Z value, I'm sorry. A Z value, cool, right? And it started out at 0, 0. And let's go ahead and color the maze where we're exploring so we can see it, right? You might not want this in your production game. You might want it in your production game. We'll say brick color green. So we're going to make the floor tiles. These are the floor tiles. We're going to change them to green as we're working through our maze so that you can see it. It'll look cool. And I'll just put a little tiny weight there so that you can see it flash for a little bit of time. All right, and now what we're going to do is we're going to get this neighbor. We're going to get neighbors of the cell. How do we do that? Well, we have this thing called get unvisited neighbor. And we're going to pass in our Z and X values. Let's take a look at get unvisited neighbors. That, we're going to have a table neighbor. We're going to initialize it to nothing. And let's put some notes here. So I'm going to put in a value for north. I'm going to put a 0 in if there is a north neighbor. I'm going to put a 1 in the table if there's an east neighbor, and etc. for south and west. 3 for west. Cool. So we could have feasibly 3 neighbors, not 4. If it's an interior cell, we have to enter in. So the one to that side is going to be visited, and then you could have 3 other values in this table. So let's go ahead and start with north. All right, so north, we're going to check, make sure we're not at the top by checking to see if Z minus 1 exists. So if you're at the 0 row, Z minus 1 is not going to exist. And if it does exist, right, we're going to say Z minus 1. Notice I have this not. I'm going to say not visited. Then. So what we're doing is we're saying, hey, is it there? If it's there, is it not visited? Right? And then we'll say table insert neighbor. That's the table. And then we'll insert a 0 saying, hey, if these things happened, we have a north neighbor that has not been visited. It exists and it hasn't been visited. So I'm going to copy this, paste, paste, paste. We're going to have the east. That's east. All right. So east is going to be an X thing, right? And that's +1. That's to the east. So get rid of that Z minus 1, X plus 1. We're going to just make sure that row exists or that column exists and it was not visited. If that is true, 0. All right. And now this one is going to be north. It was north. We're going to make it south. That plus 1, plus 1. And what do we have there for that? That's a 2. Oh, I should have known that. 2. And then this one's going to be west. Right? So west is also, it's like this, but it's going to be a -1. Right? So copy, paste, paste. It would have been quicker just to type it. Negative, negative. So that's the west is to the left, right? And that's a 3. And now we could possibly have 3 values in here. Let's return neighbor. Oh, let's make that S because it's going to have multiple values, right? Neighbors, 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 neighbors. I'm also checking to see if I have any errors. Neighbors, neighbors. Cool. If you get errors, it's a good chance it's here. All right, that's looking good though. So let's continue with our search path, right? So we went up to neighbors, we did some neighbors. Come down here after get visit neighbor. What could we have? Well, we might have something. We might have a neighbors table that has more than one entry in it, right? So this is the number of entries in this table. If it's greater than 0, we're going to do stuff. But we could get to a point where we exhaust all the visited neighbors. So we're going to have an else there too. Just be ready for that. All right. So if we have neighbors, we may have one, we may have more. Let's go ahead and get a random direction if we have more, right? So the table will have between 1 and that many elements in it, right? So we're going to get a random number inclusive of 1 and the number of neighbors. And then we'll go ahead and get a variable called next cell dir, right? Neighbors IDX. So we got a random neighbor. That's the whole randomness of this whole algorithm, right? So if next cell direction equals 0, and remember that was north, right? North, then maze Z and X north path is true, right? So we just added that to our table, that field. Let's go ahead and do some copying, right? Boom. Okay. So if that's true, let's go north, right? How do we go north? We go north on the Z. We go -1. And if we go north, we know that the south path is good because we just traveled it. And if we went north, we can now say that that cell was visited, right? We just did it. We just got there. And then we're going to go and we're going to get our table, insert the stack. We're going to insert that new value. So we're going to have zval equals z minus 1. Whoops, that was the next. Z minus 1. And z value is going to equal, oh my God, x value is going to be equal x. All right, and those are curly brackets. Let me get rid of that IntelliSense. Let's go and do that again because I was like babbling. So we have curly bracket, z value equals z minus 1, x value equals x, right? Because we moved up in the north direction. Cool. Now, luckily, these other ones aren't going to be that different. So we're going to copy this. Different enough where we can't really make a good function, but close enough where we can do some copying. Control V, I just pasted it. All right, so that's going to be east, right? East. Oh my gosh, here we go, east. And east is going to be, we're not going to do any Z stuff. We're going +1, so we're going to the right, right? Oh, and that's not a north path, that's an east path. And if we went to the right, we know that our west path was good because we just took it. Let's get rid of that, and let's put a +1 here. Whoops, that's an underscore. +1, visited equals true. Because we're there, right? Oh, and don't forget to change these. Get rid of that IntelliSense. Oh, it keeps popping up. I don't like it. Yeah. That was a new Roblox feature. Within the last year, I think they put that IntelliSense up there. All right, that looks good. And let's go ahead and do another one. We'll say else. Let's grab this. Oh yeah, south is a lot like north, so that'll be even easier. I copy that, Control C, Control V. And then this is going to be south. That's a 2. Cool. If you guys think I'm making a mistake, just remember it because I probably am. All right, so that's a plus. That's a plus because south is going down, so it's going to be plus to the Z. We have to switch these. Right, and that's going to be north, right? We're going north. We're not going north. We're going, yeah, if we went north, then we know that the north path, oh my gosh. If we went south, we know that the north path is good. Whew. Yeah, here we go. And then plus. Oh my gosh. We're almost done. We're almost done. Don't panic. I'm not losing it. Well, a little bit, but I got this. All right, so we got a west, and that's a 3. All right, so west is going to be negative. Negative, negative, negative. These are going to switch, right? We went west, and then this is going to be an east. All right. Wow. If we didn't make a mistake here, that's going to be amazing. But even if I did make a mistake, I'm just going to pause the video and fix it and show you what I did. All right, but I think we got it. All right, so there is a possibility that there's no neighbors in the table. We're not going to have a next cell. What we'll do there is we'll say table, and then we're going to remove from the stack the top element, right? And that's called a pop. All right, and now if we got all the way down here, we're going to return true. All right, this is the maze generation algorithm. We're just not removing walls and redrawing yet. So let's go ahead and do that. All right, so let's go ahead and give this a shot. We have our blank world here. Let's hit play. We should see tiles light up green. And let's look at the output window because there's a good chance we're going to get an error. Oh, look at that. All the tiles are green. Can we get it? We can't quite see that other one. Oh, here we go. Nice. Let's change the size of our grid just to make sure that we're not having any errors. There still could possibly be errors up here where we're assigning walls. So we just have to keep that in mind. I think I got everything right. But I'm going to change this column to make it bigger than the rows just to make sure we don't get an overflow error. Go ahead and play. Let's scoot up. And there you go. All right. Looking good. Let's remove walls and redraw the maze, and we're going to be done. So that was essentially the algorithm, right? We had the search. Now we just have to show the results. So we'll have redraw maze. It's going to look a lot like when we were creating our walls. So you know what I'm going to do? I'm going to cheat. I'm just going to grab these 2 lines of code because those for loops are kind of a pain. Redraw maze. We'll say cell, right? It's going to be a maze cell, Z and X. If cell dot visited, then let's color it, and you can pick whatever color you want. Cell tile brick color equals brick color white. I'm doing white. And then we want to remove the walls based on the paths. So if the cell north path exists, it's true, then we'll remove wall, and that will be cell north wall. Remember, we added those up when we created the walls. So there could still be an error here. We haven't checked that yet. Let's just be prepared for that. All right, so that's the north, east, south, west. north, east, east, south, south, west, west. All right, we don't have to return anything, but let's go up here and remove our wall. How do I remove a wall? I don't actually remove the wall. What I do is I'm going to get the size of the wall, wall size. I'm going to get the position of the wall, wall position. I'm going to set the size vector3 new s dot capital X. And then this is going to now be floor height, right, for the size. So I'm basically just shrinking the wall down so that it blends in with the floor. And I'll say, ooh, SZ, right? So the sizes won't change on the X and the Z, just the height. And I'll do wall position. Oh, did I spell position wrong? I did. Hold on a second. Wall position. Nice. Wall position. Vector3, new, PX. And then we'll do floor height position. It was wall height position, PZ. All right. And then we'll go ahead and we'll change that tile. Oh, you know what? Do we need to change it? Probably not. Let's just put it in there anyway. Brick color, brick color white. Yeah, it looks like, oh yeah. Because this is for the floor tile. This is for the wall, right? So that it looks like the wall looks like part of the floor. You will need that. All right, we are done. Let's try it. Oh man, under 40 minutes. God, I hope I don't get an error. Oh, I got an error. No. Let's go and check where our error is. I'm just going to pause it. Oh, it was actually easy. All right. So see where it says redraw maze? We just forgot an end. Boom. You guys probably even saw that. Let's try it. Man, I thought I was going to get through this whole thing without an error, and I got an error right at the end. Nice. Sweet. Let's make it bigger. Let's go ahead. Let's make it 11 by 11. Let's make it actually bigger than that. 13 by 13. And then let's make the walls thicker by 3. And then let's make the wall height, make it taller. There we go. Let's run it. Look at that. That's cool. Nice. All right. So, and you can take the weights out. It'll go faster. It's just going through and it's checking every single path. If it exhausts the path, it backs up until it has an unexplored path in there. And we are all done. That's pretty cool. Recursive backtracking maze generation.